In science, our word for balance is equilibrium. You've heard of it. When the balance of some natural system gets disrupted, we say that it's out of equilibrium. But that's not always a bad thing, because nature usually finds a way to restore the balance. We tend to think of chemical reactions as having a beginning and an end. You start with some reactants, some chemistry happens, and you end up with the products, and that's that. But that's not that, because you don't usually end up with pure products. Many chemical reactions seek balance too, and just like us, they have to work through the stress in order to find it. It's common, because it's usually helpful, to think of chemical reactions as simple, straightforward processes, but in reality, many reactions never finish. Ever. When reactants react to form products, what we usually mean when we talk about chemical reactions, it's technically called the forward reaction. But sometimes there's an opposite reaction that occurs, with the products changing back into the reactants. We call this a reverse reaction. Now, exactly what kind of reactions do this and why is hard to describe without busting out some 200-level chemistry kung fu, but reactions are reversible when they can go forward or backward without any extra energy being used. Remember, this isn't just one reaction happening once, it's billions and trillions of reactions, and some of them might be going one way while others are going another way. And when the forward and reverse reactions occur at the same rate, that's called chemical equilibrium. And even though we all like the idea of balance in our lives, in this case it's not always a desirable thing. And that's why reactants like this are written with a double arrow, indicating that the process runs both directions. Like, chemical equilibria can be disturbed by changes in the concentration of one or more substances, or by changes in temperature or pressure. We describe these changes based on which way they force the equilibrium. We say a change shifts the reaction to the right if it tends to make more products form, and to the left if it tends to make more reactants form.